Okay, metal spinning process or spin forming. Spinning is a metal working process by which a disc or tube metal is rotated at high speed and formed into axially symmetric parts. Okay, that means metal spinning is the operation of shaping thin metals. It is the operation of shaping thin metals by pressing it against a former while it is rotating. Okay, we are pressing the metal against a former. Okay, how can we produce this former? The shape to be generated on the workpiece is made of wood or metal and is called a former. Okay, the shape to be generated on the workpiece is made of wood or metal and is called a former. Products like cooking utensils, bowls, lamp reflectors, and bells of some musical instruments can be made by this process. Okay, we'll go to spinning process. Okay, here we can see that a mandrel is placed and it can be rotated. Okay, a blank is placed and blank can be pushed by manually or by using any machinery. Okay, when the blank and the former rotates, the operator applies localized pressure against the metal, causing it to flow progressively against the former. Due to the pressure applied to the rapid revolving blank, causing it to assume the shape of the former, rotating with it. Pressure applied on the rapid revolving blank will cause the shape of the former rotating with it. Okay. The mode of deformation involves, the mode of deformation here is both bending and stretching. Okay. Next, shear spinning. What is shear spinning? There is a difference between the conventional um, spinning process and shear spinning. In conventional spinning operation, the area of final component is approximately equal to the flat sheet metal blank without reducing the wall thickness. Whereas in shear spinning process, reduction of wall thickness is induced. Okay, here a reduction of wall thickness we can see. Okay, here we can see a shear spinning operation. In the figure, it is clearly explained about the shear spinning operation. A blank is placed above the spinning material and the tools or the rollers are stretch used to stretch the blank on the outer side of the mandrel. The thickness of the walls of the metal can be controlled by the adjustment of the roller spacing between mandrel and the roller. Okay, the final wall thickness is achieved by controlling the gap between roller and mandrel. In this process, it produces an axisymmetric conical or curvilinear shape while maintaining part's maximum diameter and reducing its thickness. Here we can use a single roller or two rollers. If we use two rollers, we can balance the force acting on the mandrel properly. Okay, parts up to 3 meter in diameter can be formed by shear spinning operation. So for a shear spinning, we need a mandrel roller. Okay. Next, we will move on to tube spinning. In this process, we can see that in this process, the thickness of the cylindrical parts is reduced. The thickness of the cylindrical part is reduced by spinning them on a cylindrical mandrel using a roller or rollers. Okay, the parts can be spun forward or backward, and the operation can be carried out externally or internally. Here we can see the external tube spinning and internal tube spinning. The difference is that tool is placed outside or tool is placed internally. Okay, according to the position of the tool, we can say that it can be external tube spinning or internal tube spinning. In external tube spinning, tool movement is outside the mandrel. Okay. In internal tube spinning, we are using dies, and inside the die, we are moving the tool. Okay. Next, we'll move on to tube bending. Tube bending. Metal forming operation used to permanently form pipes or tubings is called tube bending. Okay, it is a metal forming process used to permanently form pipes or tubings. At the time of tube bending, the wall on the inside of the bend is in compression and the wall at the outside is in tension. These stress conditions cause thinning and elongation of the outer wall, thinning and elongation of the outer wall, and thickening and shortening of the inner wall. So we can say that the outer walls are thinned and elongated, while the inner walls are thickened and shortened. Okay. Bending and forming tubes and other hollow section require special tooling to avoid buckling and folding at the bent corners. Okay, in tube bending process, it will always have buckling or folding at the bend corners. So different types of bend machines are used. The different types of bend machines are rotary draw benders, compression bender, ram bender, three roll benders. Okay, we can see the tube bending operation. Here we can see a mandrel, wiper, bend die, clamp die, pressure die, etc. Okay. So first we will move on to rotary draw benders or mandrel benders. Okay, rotary draw tube benders or mandrel benders. Okay, it consists of several tooling components. Okay, here we can see bend die, clamp die, pressure die, and wiper die. We can see in this figure mandrel. Okay, mandrel is placed inside the tubing. Mandrel is always placed inside the tubing. Okay, a mandrel controls the flow of material at the point of bend in order to maintain the shape of the tube as it sets into the arc of the bend. Okay. Next, the pressure die. Pressure die holds the tube against the bend die under pressure. Next, clamp die. Clamp die clamps the tubing material to the bend die as it rotates to form bend. Next one is bent die. Bend die is also called former die. Here the bend die is rotating. You should note that in rotary draw tube bender, the bend die is rotating. It is moving. Okay, it is a moving part. Bend die is the form against which the tube is clamped and then draw around to produce bend. Bend die is the former die which is a form against the tube is clamped and then draw around to produce bend. Viper die. Viper die prevents the formation of wrinkle on the inside radius of the bend. Okay. Next, we can see a compressor die. Sorry, compression bender. Okay. Compression bender. The main component is compressor die. Okay. In compression bender, its operation is similar to rotary draw benders. However, the bend die remains stationary and the compression die moves over the tube to bend the tube. Okay. Next, ram benders. A ram with a head or the radius block attached to it produces bending. Okay. In ram bender, a ram with a radius block that presses the tube or pipe against two counter rollers or wind dies produce bending. The radius on the radius block tooling determines the form of bend. Okay, next we will go on to 3-roll tube bending. Here the bending is done by these 3 rollers, in which one roller is a working roller. Okay, in this process 3 rollers are arranged in a pyramid shape. It is used for large bending radii. Roll benders are similar to ram bending, but they use a working cylinder and 2 stationary counter rollers. The positioning of the 3 rolls determines the form of bend. Okay, thank you.